Hi viewers, welcome to Dilemma Solution. Today we are going to see about speed control of PMSM drive using field oriented. So this is a block diagram for field oriented control of PMSM. PMSM nothing but a permanent magnet signal. Here you can see that here we are going to measure the speed of the that means here we are going to measure the angle, rotor angle. Here we are measuring the rotor angle in the mechanical form. That rotor angle going to be converted into electrical form by means of this conversion p by 2, number of poles divided by 2. And then here we are measuring that based upon the rotor angle we are measuring the speed, or else we can measure the speed directly. Then we need to compare with the reference speed. This is known as reference speed. And then this the speed error when we process the speed controller. Normally we are using only PA controller. We can use PA controller. So that PA controller will be generate the reference current. This current in field oriented control, this is known as IQ. That is nothing but IQ star, quadrature axis current, and then ID will be equal to 0 in this case in field oriented control. Based upon this IQ star and ID star, we need to generate reference current. Here, that reference current regulator. And reference current regulator, just we need to generate an three-phase current IE star, IB star, IC star. So this can be generated by means of DQ to ABC conversion. Based upon this value IQ star and IB, just you have to use transformation PQ to ABC conversion. By using this conversion, we are going to generate that IA star, IB star. This is going to be considered as the reference current. This reference current going to be compared with the PMSM stator current. Just you have to measure the stator current and it is going to be compared with the IB star and IC star. And then is going to be processed with hysteresis band current controller. This hysteresis band current controller will generate the pulse for this three-phase voltage source. So based upon this pulse, the speed of the PMSM will be controlled, and then IK star and ID will be controlled in the PMS. This is normal working of the field oriented control of PMSM. Let's start with the implementation of the same concept in the MATLAB. Further, I am going to show you the implementation. This is a model created for that field oriented control of PMSM for speed control. Here you can see that this is a DC source, and here we are using universal bridge. Then is directly going to be connected with the PMSM motor. And here we are measuring that the PMSM parameter like stator current IA, IV, IC. And then here we are measuring the speed of the PMSM. And here we are measuring the electromagnetic torque of the PMSM. And then here we are measuring that rotor angle, the mechanical rotor angle in radian. First, I'm going to take that means I'm going to compare this actual speed with the reference speed. Here I'm using step signal for providing the reference speed command, and then it's going to be compared, and then error speed going to be processed by a PA controller. The output of this PA controller is going to be taken as IQ reference, and FOC the ID reference is equal to 0. Here I'm going to take constant block for making ID reference equal to 0. So next I'm going to combine that ID reference IQ reference by means of max block, and then I'm going to convert this ID reference IQ reference, that means by convert it into ABC form. So by means of this DQ not to ABC conversion. Here you need to provide another input, nothing but omega t for conversion of DQ not to ABC. Further, this omega t can be taken derived from the rotor angle of the PMs. Here we are getting the reference current IAIB IAIB reference current going to be compared with the actual AVC. So this reference going to be compared with the actual IAVC, and then here we are getting error current. So the error current going to be processed via hysteresis controller, and then in this hysteresis controller will be generate the pulse. Here we are using a 3-phase voltage source inverter. We need 6 pulse. That's why we are taking the complement of this pulse and then is converted into 6 pulse for the voltage source inverter. So this pulse will be given to that IGBT drive voltage source inverter. So this is going to be control the speed of the PMSM. Now I am going to show you the reference current, the reference speed. So initially I am going to fix the reference speed is equal to 100 radian per second, and then finally that it going to be changed to 125 radian per second after time of 0.05 seconds. And also here I am using that load initially 6 Newton meter and finally the load will be equal to 3 Newton meter. So next we have to see the response, and also and in this side you can see that we have different scope. This scope is for measuring the getting pulse, and this scope is for measuring the voltage from that means voltage across that PMSM, and then current, stator current. So this will be used for measuring that actual speed and reference speed, and this is used for measuring the electromagnetic torque of the PMS. Now I'm going to open all four and then place in this equation. After that I'm going to simulate the model. Now I'm going to simulate this model. Now we can see that the speed initially may fixed at the reference with command is fixed at 100 radian per second. This actual speed command, so it will be reached nearly 0.02 seconds. So it maintained around 100 radian per second. We track the reference speed command after 0.02 seconds. So in the time of 0.05 seconds, the speed command changed from 100 to 125. Because of that, the actual speed of the PMSM also can be changed from this point to this point and then reach here around 0.06 seconds. And also it track that PMSM speed with the reference speed command. During initial starting period, here during this period from 0 to 0.2 second, this is voltage of the output voltage of the inverter. During that tracking of speed command, after reaching that reference speed command, this voltage across that PMSM or output voltage of the PM inverter. And then during starting, it have high starting current. After it reach reference speed command, it have some steady state current. And this point after 0.05 seconds, the speed command change from 100 to 125 radian per second. Because of the voltage of the inverter will change, and also you can see that some increase in current during that speed command variation in the PMSM. After reaching the speed to the reference speed command, then it has steady state current. And then you can see here this is a response of electromagnetic torque. During starting, it have high starting current. After that, it have high starting torque, and then after reaching the reference speed command, it has steady state electromagnetic torque. And also during changing speed command, have some disturbance in the electromagnetic torque response. After reaching that reference speed command, we have steady state electromagnetic. So this is a variation of pulse from that switching logic circuit for the voltage sourcing. So this is working of field oriented control of PMSM for speed control. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming video. Thank you so much.